Okay, we're going to go over quotient rule for differentiating a function. So essentially for finding derivatives, say we have some function, we'll call it h at x, is equal to a function, so the numerator of our fraction, if it's a quotient, over g at x would be the denominator of this fraction here. If we were to find the derivative, so h prime x, it's the equivalent of this function. So what we do is we take the the g at x and multiply by the derivative of f at x. So we essentially derive the top, multiply by the bottom. That's the first part. We then subtract by deriving the bottom and multiplying by the top. That's the second part. And then all divided by the bottom or the denominator squared. So what we're going to do in this question is, just so this makes sense, what we're going to do, I'll change the colors a little here. We're going to call the top of this function f at x, and we'll call the bottom of this function our g at x. Okay, and we'll color code this to help this make sense. Technically, our y prime, whoops, wrong button, sorry. Our y prime would be our h at x. But say we're finding y prime. Well, y prime will be equal to, okay, it'll be equal to g at x times f prime x. Okay, so f prime x. So in other words, and we'll highlight it. I guess I'll use red, might be too dark. Let's see. Oh no, it works. This being our f function subtracted by our g prime x. So the bottom of our function, g prime x, times the original f at x, and all divided by our g squared. Oops, sorry. Our g. Works what's better when those work. Our g at x squared. Okay. So we'll highlight this just so we can see. Blue. Let's see if that's too dark. It kind of works. Can you see that? Okay, good. So we're going to derive these functions on the side. So there's this is our f at x. Our f prime x is the derivative of this, and this just ends up being a simple derivative because the only exponent here is on the x. We bring it down, and we're left with what?
4.
Exactly, 4. And what would our g prime x be in this case?
3x. 3x squared.
Yeah, 3x squared. Very good. Okay, so essentially we're going to take these values. Let's use this. We're going to take both of these values, and they're going to be what we're going to be replacing things with. And we're going to take the original values, and they'll replace our original functions. Okay, so we've kind of tried to color code it a little here. So, and we'll write the rest in. Actually, I guess we'll write y prime. So our g at x, the original g at x, is x cubed minus 2 times, and f prime x is just the value of 4. Okay. Subtracted by g prime x, which is just our 3x squared, times our original f at x, which is our 4x plus 1. Okay, and this is all divided by our original squared. So we're going to just write the original in, and then we'll square it on the bottom. Okay, so this is essentially it in its least simplest form. Okay, so we've just replaced values, we've found the derivatives of specific parts of the equation and plugged them in. The next thing we have to do is simplify everything. So from here on in, we'll write everything in black. Okay, so that was just to help us color code. So y prime x is equal to, so this is a distributive property, and we need to distribute the 4 into both of these functions. So this becomes 4x cubed minus 8, okay? And technically we'll do this all in one step. I think you can do it. If we have this negative here, essentially we distributed into this. So think of this like being negative 3x squared, and then we distribute that into both of these numbers. So negative 3x squared times 4x. Do you know what that will give us?
Negative 12x cubed.
That's right. Okay, and negative 3x squared times positive 1?
Minus 3x squared.
Perfect. Okay. So now we know we have some like terms on top, and then on the bottom, okay, I guess we'll leave that in blue. On the bottom, just we'll do one step at a time. It's the same as writing, oh geez. There we go. It's the same as writing this binomial twice. Okay. So essentially that's our FOIL, if you remember doing FOIL. Okay, good. So on top, we'll collect our like terms. Our like terms here are the negative 12x cubed and the 4x cubed, which is going to give us negative 8x cubed minus 3x squared minus 8. Okay. And on the bottom, we'll quickly put this through, and I think I can do this all in one shot here. This is going to give us what value? We go first and the second. So we add the two exponents. So we get x to the power of 6. Perfect. And then x cubed times negative 2.
Negative 2x to the power of 3.
Yep. Same idea. So same thing. And then finally, negative 2 by negative 2 is our positive 4. Okay, so we need to simplify the bottom of this function. And looking at the top, is there really a common denominator or anything we can take out of here?
No.
No. And if we were to do any type of factoring, we'd have to use synthetic factoring. So we're probably going to leave it as the way it is. Okay. And by synthetic factoring, I mean what we'd probably have to do is at some point we would essentially have to be adding 0x in terms of there, but we're not going to do that. We're just going to leave it the way it is right now. Let's put this back in black. Good. All over, and we'll simplify the bottom of this. Restart this. We have our x to the power of 6. This becomes negative 4x cubed plus 4. Now this is something we may be able to factor. But again, because we're not doing any factoring on top, we're probably not going to be able to simplify this much farther unless we were to break this all down. Quickly looking at it, I don't know if they want us to do that or not, but essentially this is it. Now we can put it in factor form if we want, or we don't have to, but essentially this is our quotient rule. We've completed everything we need to and simplified in a relatively decent fashion. Okay, let's take a look. Let's see. What the funny thing is, I don't know if we recorded that. Oh, we did. Okay, we're going to look at the same question, but this time we're not going to look at it as a quotient. I'm going to make this a product. And the way I'm going to go about doing that, okay, is essentially the value on the bottom is to the power of 1, okay? And we could split this. So what I mean by that is the idea is it would look like this. If I were to split this up, we get y is equal to 4x plus 1 over 1 times, okay, 1 over x cubed minus 2. Right? Technically that's above, but it's less simplified. This is like an expanded form of it. And instead of having a value on the bottom, because this is the power of 1, I'm going to change this exponent to be a negative 1, and it's going to end up as a product rule. So what's going to happen is we're going to have y is equal to 4x plus 1, and I'll write it over 1 just so it still makes sense. And this one is going to be x cubed minus 2 over 1, but this time to the power of negative 1. Now those divided by 1s aren't very important. They're not going to change anything when we divide by 1. So this can be rewritten as 4x plus 1 x cubed minus 2 to the power of negative 1. Okay? So now we're dealing with a product. Okay? And if you remember the product rules, we find the derivative of the first one times the original of the second, and then vice versa. So we'll do that very quickly here. Thank you, Tracy. So the idea being, if we find a derivative of the first one, derivative of that is just the value of 4, right? Times x cubed minus 2 to the power of negative 1. Plus the original of the first, which is 4x plus 1. And on the second one, we have to use a chain rule, right? That negative 1 comes down in front. We have x cubed minus 2. And technically to the power of negative 2. And then we derive what's inside, and inside would give us 3x squared. Okay. So it looks a little complex, but the actual deriving part is probably a little simpler than the quotient rule, the amount you had to remember. From here, we can try to collect our like terms. Okay. Now this here, I'm going to actually turn it back into a fraction, the first one. So it actually reads 4 over x cubed minus 2. Does that make sense to you? I essentially just made that exponent positive again. Plus, and I'll do the same thing on this side. Okay, I'll leave what's up there. So we have 4x plus 1, just doing less steps, times negative 1, times 3x squared, all above x cubed minus 2 to the power of 2 here. Okay, so in this case, it's probably going to make things a little more difficult just because of what happened here. We're going to have to get common denominators in order to put them together. But I'll simplify the top of this. Okay, so y is equal to, again, 4x cubed minus 2 plus, and on top, think of this like negative 3 being multiplied by all of those values, so it becomes negative 12x cubed, and then negative 3x squared. Does that make sense on top?
Yeah.
Okay, and then on the bottom, we have the original, which is our x, oh geez, I did it again, which is our x cubed minus 2 squared. To make these like terms, we're going to have to multiply the first one by x cubed minus 2, both the top and the bottom, right? Minus 2. Okay. What that'll do is give us our bottom here, and like we said before, and I'll relate this back to what we did, this becomes y equals 4 x cubed minus 2 plus our negative 12x cubed minus 3x squared all over our x cubed minus 2 squared. Now, if you remember, this was our g at x squared, and we expanded it. But we don't really need to expand it. In fact, that factor form, like we said, that was the factor form. We expanded in the one we didn't need to. Let's simplify the top and see if we got what we would have got before. Or what we did get before, sorry. This becomes 4x cubed minus 8 minus 12x cubed minus 3x squared. I'm going to focus on the top right now. I'm going to say the bottom's the same. Y is equal to, this becomes negative 8x cubed. Does that make sense, those like terms? Okay, minus 3x squared minus 8, which is, I think, exactly what we got before. And on the bottom, we didn't change anything. We're going to leave it in that form, okay? X cubed minus 2 squared. So if we look at both of the pages here, quickly try to look at both of our answers. Okay, look at both of our answers here. On top, we had negative 8x cubed minus 3x squared minus 8. This is the exact same thing we had here. Our bottoms are a little different because we expanded it in this case. But this bottom here, 3x minus 2 squared, is the same as this. And had we expanded it, we would end up at the same answer we got on the other page. Same question, just two different ways of doing it.